Planets are the major members of our solar system, moving in generally the same plane around the sun. Between the planets are the minor members of our solar system. Comets that are visible to us only when they pass near the sun. Meteors, or shooting stars, whose glowing trails are produced when meteorites plunge into the Earth's atmosphere and produce hot gas clouds. And the planetoids, small planet-like bodies that revolve about the sun, reflecting its light. Astronomers use telescopes to photograph light reflected or produced by comets, meteors, and planetoids. By using a spectroscope, astronomers can spread the light of these bodies into a spectrum to get information about their composition. Astronomers use radio telescopes to study meteors by broadcasting radar waves and recording the echoes in photographs such as this. Let us see now how astronomers attempt to explain some of their observations of comets, meteors, and planetoids. Generally between the orbits of Mars and Jupiter, in a region called the planetoid belt, we find the planetoids, sometimes called asteroids. About 2,000 of the larger planetoids, ranging in size from about 1 mile to 500 miles in diameter, have been officially named or numbered. Thousands of smaller planetoids have been observed. Telescopes are necessary for us to see all but the largest of the planetoids. When the telescope is used to photograph the planetoids, clockwork moves the telescope to follow the stars across the sky. On photographs made by exposing film for several hours, the stars produce bright round images, while elongated images, called trails, are produced by the moving planetoids. This is the trail produced on a photograph by the planetoid Eros, which sometimes comes within 15 million miles of Earth. Most of the planetoids stay close to the plane in which the planets move. How can we explain the formation of the many small planetoids between the orbits of Mars and Jupiter, where we might expect a single planet? Possibly the strong gravitational forces of Jupiter are responsible. Some scientists believe they formed this way. Perhaps several small bodies, about the size of the largest of the planetoids, formed between Mars and Jupiter. Then, in the course of thousands of millions of years, collisions occurred, which produced many smaller fragments. From such a series of collisions, the thousands of small planetoids may have been formed. These bits of planetoidal debris may also be partially responsible for another kind of interplanetary wanderer that we sometimes see flashing above us in the night sky. These are the meteors, or as they are often called, shooting stars. Of course, they are not stars at all. Most often, meteors are caused by particles called meteorites that are usually not larger than grains of sand. They blaze into hot gas as they plunge into the Earth's atmosphere. Not all meteors are consumed in their collision with the Earth's atmosphere. Occasionally, a solid part of a meteor reaches the Earth. Then it is called a meteorite. Large ones form holes called craters. This meteor crater in Arizona is 1 mile wide and several hundred feet deep. It was formed thousands of years ago by the fall and explosion of a meteorite, probably more than 100 feet in diameter. Some of the craters on the moon probably were formed this way. Only a few large meteorites reach the Earth each year. Most, like these, weigh a few pounds. Though many meteorites have been found in many parts of the world, most are of 2 types. There are stony meteorites that look like ordinary rocks, and there are metallic or iron meteorites that are mainly composed of iron and nickel. A few meteorites are combinations of the rocky and metallic types. Tiny meteorites that never get through the atmosphere can now be studied in space with this type of device. It is a space capsule designed to investigate what are called micrometeorites. When such a capsule is in space, paddle arms open, exposing surfaces that will record any collisions with micrometeorites. Capsules such as this are carried into space by rockets. Recovered on Earth, the capsules have brought back evidence that the Earth is surrounded by a vast cloud of micrometeorites too small to do serious damage to a space vehicle. Periodically, the Earth's orbit carries it through swarms of these tiny particles, resulting in meteor showers, such as the one recorded in this drawing that took place in 1833. Meteors filled the sky in a spectacular display. The explanation for meteor showers that recur yearly or in longer periods can be found in a third type of wanderer between the planets, comets. When a comet is photographed, the telescopic camera is moved to follow the comet's motion. This causes the stars to appear as little trails on the photograph. A comet is composed of an enormous gaseous head that is usually many thousands of miles in diameter. Streaming out from the head is a long tail, frequently millions of miles long. The source of a comet's tail is material in its head. Within the large head is a smaller, sharply outlined nucleus, as shown in this drawing, probably a mass of frozen gases and meteoric material. As the comet approaches the sun, it is heated by sunlight. This heating thaws the frozen gases on the surface of the nucleus, releasing some of the meteoric material. The gases absorb sunlight and glow. Pushed by the light and electrified particles from the sun, sometimes called the solar wind, the gases form the long tail of the comet that points away from the sun. Some comets travel around the sun in periods of less than 100 years, while others come past only once in thousands or millions of years. Let's follow one of the best known of the comets, Halley's comet, along its orbit that carries it around the sun about every 76 years. The elliptical orbit of Halley's comet, as represented here, extends from within the orbit of Venus on the left, where it was last seen from Earth in 1910, to its farthest point in space beyond the orbit of Neptune, where it was in 1948. Then Halley's comet was not much more than a nucleus of solidified gases and meteoric particles, starting to fall back toward the sun. By 1970, it will have crossed the orbit of Neptune. By 1980, it will have crossed the orbit of Uranus. Its speed is increasing. By 1985, it will have passed the orbit of Saturn and be approaching the orbit of Jupiter, and then rushing past it. Now, as it approaches Earth, the tail of the comet will form as light from the sun is absorbed by the nucleus. Viewers from Earth around 1986 will watch the tail of Halley's comet grow to perhaps more than 100 million miles in length. Then, as the comet rounds the sun and moves away, tail first, the tail may shrink or be blown away. In the process of developing tails and losing them, comets seem to release swarms of meteoric materials that follow along the same orbits. In time, a swarm may lag behind or move ahead of the parent comet and gradually spread out around the full orbit. It is these swarms of small particles that are believed to produce meteor showers, which we see periodically. While meteor showers are most likely the result of material lost from comets, comets may be made of material left over after the formation of our system of planets. So we've seen that sometime during the formation of the planets of our solar system, a kind of debris was probably left in space, revolving around the sun. This debris makes up the comets, meteors, and planetoids of our solar system.